everybody, how are you doing? It's a mathematics teacher, the research in the field of okay. So learners and the teachers, okay, colleagues, and we will try to focus on discriminant formula of Mourad Sultan Ezouidi. Okay, formula it's very important. You can use to find out the roots of any polynomial to the power n, okay? In other words, any polynomial raised to the power n. So let's focus on this method, okay? We are going to, at the same time, find the zero of polynomial 4, okay? So let's start. Just a moment. Okay. I wish that everyone is watching the lecture. Okay, it's very important, especially for mathematics teachers and students and professors. Okay, apply this new method. Okay, of Mr. Mourad Sultan Ezouidi. Okay, I'll just reduce this. Okay, so learners, we are going to focus on this polynomial to the power 4 or raise it to the power 4. P of x equal x to the power 4 minus 20 times x to the power 3 plus 2097 x squared minus 19,970x plus 340 equals 0. Here you are involved to find out the zero of this polynomial to the power 4, okay, and try to figure out the roots if it is possible, of course. In general, it's possible to solve any polynomial to the power n, okay, whatsoever the polynomial, we can solve, okay, of course, using the formula, the discriminant formula of Mr. Mourad Sultan Ezouidi, that is labeled sk minus 1 to the power r equal the sum from 0 to k. Let's say n minus r, choose k minus r, or where let's say k is between 0 and k, okay. Therefore, n to the power r times minus l and x at 0 to the power q, all raised to the power k minus r, okay, multiplied by l r minus 1 of order q. This is very important, okay. So before starting, just you should focus, or you should figure out L minus 1, which is 1, L0 Q, which is 20, okay, minus 20, it will be give you 20, L1, it will be positive, okay, 2097, okay, the coefficient in front of x squared terms, and L2 is the negative sign, the negative value of that is in front of x term, okay. So L2 here is minus, so it will be 19,970, and L3 is a positive number here, it will be 340. So learners, here we are going to use we told this formula, it's very important, the formula of Mr. Mourad Sultan Ezouidi, okay, it's very important, okay, every learner, every student, every teacher can use, and he can find, let's say, the roots of any polynomial to the power 6, 9, 18, 20, 30, and so on. Okay, this formula, let's say, had been discovered by Mr. Mourad Sultan Ezouidi, the Tunisian researcher, teacher. Okay, and I spent, in fact, more than 14 years doing researches and dipping into the field of mathematics. Okay, and thanks to God, I reached this formula. Not only this formula, in fact, so many formula. Okay, in this topic, we focus on this one. Okay, so let's see if, first of all, so okay, it works. This is the channel of your colleague Mourad Sultan Ezouidi. This channel was designed and created only for science, okay, only for learners who want to learn from from the beginning, okay, and to get rid of the usual and let's say concentrate on these new theorems of Mr. Mourad Sultan Ezouidi. Okay, let's focus also on the YouTube. Yes, it works. Okay, so we continue. We told learners I will use this formula. First of all, I should set k equals 0. Okay, to find the value of s minus 1 of order r, which is equal 1. This is by convention. Okay, we consider that s minus 1 of r is 1, always is 1. Okay, now we should set k equal 1, or for k equal 1, we'll obtain let's say S0 of R. I will use this formula. I will suppose that K is 1. So S1 minus 1 is 0. So it will be S0 of order R equal R, the sum of R from 0 to 1, then N minus R, 1 minus R, N to the power R multiplied by minus L is of okay L 0 of order Q, all raised to the power 1 minus R multiplied by L r minus 1 of order Q. Therefore, we just replace or substitute K with 1. We obtain this formula that derived that is derived from the discriminant formula of Mourad Sultan Ezouidi. It's very important, this method. Okay, and this one should be equal to n choose 1, okay, which is n times n raised to the power 0. This is 1 multiplied by minus L0 of order Q raised to the power 1 multiplied by L minus 1 of order Q plus when now this is when R equals 0. Now when R equal 1, it will be n minus as combination n minus 1 choose 0 and raised to the power 1 times minus L to the power Q raised to the power 0 multiplied by L0Q. Okay, so this one you can see this one is 1. Okay, this one it will be 1 also. So n minus 1 over the Q is 1. I will just write this as minus n choose 1 times L0 over the Q times n minus 1 over the Q plus n times L0 of order Q. So this one learns, let's say the combination n choose 1 is n, and this is also n, opposite, and let's say, which are opposite, are negative numbers, so they are opposite, okay. I will put this one into parentheses. It will be L0Q times minus n plus n, which in fact is 0, okay. Therefore, now it's clear that S0 is 0, okay, using the formula, the discriminant formula of Mr. Mourad Sultan Ezouidi. I will just obtain negative 4 multiplied by 20, okay, because L0Q is 20, times 1 because L minus 1 of order Q is 1, plus 4 times 20 because here plus n is 4, okay, the highest power is 4 of this polynomial, multiplied by L0 of order Q, which is 20. So it will be negative 80 plus 80 is 0 whatsoever. This is the formula when when setting Q equal 1. Okay. We proceed, continuing learners. Now we should set K equal 0, or for K equal 0 learners, we'll just obtain this formula. Okay. S1 of R is equal the sum that started from 0 to 2, because this is K minus 1. I will suppose that K is 2, okay. It will be 0, 0, 2, okay. N minus R, choose 2 minus R, N raised to the power R times minus 0 of order Q raised to the power 2 minus R multiplied by L, R minus 1 of order Q. So this one, when R equals 0 learners, we will obtain n choose 2, the combination n choose 2 times minus L0 square times n minus 1. This is 1, no need to write it, but it's certainly the formula, plus n times, now when n equal 1, I'll just substitute R with 1. It will be n minus 1. 2 minus 1 is 1. That's why here I written I had written, let's say, 1n minus 1 times minus L0 of all the q raised to the power 1 times L0 of all the q plus when n equal 2, this is, it will be learned as 2 minus 2 is 0. I wrote it here. Then n square is this times minus L0 of all the q raised to the power 0 times L1 of q. Okay, this one is 1, no need. This one also is 1, no need. It remains only, after calculation, I will obtain, let's say, C combination n choose 2 times L0 for the q squared plus n C n minus 1 minus L0 for the q times L0. This it will be minus n combination n minus 1 choose 1 times L0 over the q raised to the power 2. So this one, I can simplify this. Okay, I will use the following. I will just write these learners as I will put all the L0 for the q squared, okay, times n choose 2 minus n minus 1 choose 1, okay, plus n square times L1 over q. This one is known by the discriminant formula of Mr. Sultan Ezouidi when solving quadratic formula, okay. Therefore, here I will just continue simplifying, okay, either collecting like terms, either simplify, adding or subtracting. Here we can subtract these two things. It will be minus a combination n choose 2 times L0 for the q squared plus n square L1. So here just now, this is the formula. I will go back to substitute, okay. Here you have L minus 1 is 1, L0 is 20, and 1 is 2097. Okay, I will use my calculator. Okay, I will use what exactly? I will use minus 2, 4 choose 2, which is minus 6. Okay, minus 6 times what, learners? Times 20 squared, which is 400. Okay, then plus 4 squared, which is 16. Plus 16, we say 16, when you count, for example, counting 11, 12, 13, 14, 15, 16. Okay, we can say also 16, okay, or 14. But I prefer pronouncing pronouncing it as 16. Okay, times 2097. This one, after calculation, you just obtain this value, which is equal to 31,152. 31,152. Therefore, now I just calculate S1. We need to find S2 also, S3. Okay, we stop at S3 because n minus 1 it will end this with S index of the 3 over the R. So we continue learners. Therefore, now when for setting k equal 3, as k minus 1 will be 3 minus 1 is 2, and here is k, 3 minus r, n minus r, n is raised to the power r times minus l of 0 of order q raised to the power 3 minus r, l, r minus 1 of order q. Now learners, when r equals 0, I will just write n choose 3 times minus L0 of order q raised to the power 3 times L minus 1 of order q is 1, plus when n r equal 1, it will be 3 minus 1 is 2, and n minus 1. I wrote it here. Combination n minus 1 choose 2, then times n raised to the power 1, it will be n to the power 1, or just n, times minus L0 for the q, 3 minus 1 is 2, times L0 of order q, because 1 minus 1 is 0, that's why here we put 0. Then plus when n equal 2, 3 minus 2 is 1, and n minus 2, I wrote it here, 1 and minus 2, then n squared because r is 2. Okay, times minus L0 for the q raised to the power 3 minus 2 is 1 here, times L1 of order q, because 2 minus 1 is 1, plus when now n equal 3, it will be n minus 3 choose 0, because 3 minus 3 is 0, So no need to write it, is 1 n cubed times minus L 0 for the q to the power 0. We wrote it here, learners. I will appear this as that, so you can see it. Enter. Okay. Therefore, times n cubed, we told 3 ik minus L to the power q over the 0, all multiplied by L12 cube. Okay. So this one is 1, this one is 1. You can simplify it. After calculation, learners, you will find S2 equal, I will put L0 of order q to the power 3, and this one also is L0 of order q to the power 3. I will put into parentheses or a common factor. I will put this here. Then it remains only minus combination and choose 3, minus combination and choose 3, plus what, learners, plus n times combination and minus 1 choose 2. I put here, then I will simplify this. Minus what? Minus n minus 1 choose 1, and square L0 of or the q raised to the power 1 and 1 over the q. I wrote it here, plus the last one and cubed L2. Okay. Now, after calculation, learners, we told you we put this into common, let's say common factor. We find this one is equal to, just a moment, is equal to this minus n choose 3 plus n minus 1 choose 2, in fact, is equal to 2 combination n choose 3 times what? Times this one, which is L0 cubed minus c n minus 1 choose 1 and square L0 for the q and 1 plus n cubed. Therefore, I will just calculate the value of this. Okay. And at the same time I'm calculating, you can also use your calculation and figure out the answer with your researcher, Mourad Sultan Ezouidi. Therefore, learners, I will start from the beginning. Here we have S2 about R is 2 simply because here this is combination. Say 1, 2 means 2 multiplied by 3n, n is 4. So just 3n, 3, 4 is 4. So it will be 2 times 4 is 8. Okay, 2 times 4, I will write it as it is. Okay, 2 times 4. Okay, times what? Times L0 for the q to the power 3 means 20 a cubed. Okay, 20 to the power 3. Okay, then minus 2 times 4 square. Okay, minus 2, because this is C1 and minus 2, n is 4. It will be C 4 minus 2 is 2, C1 2 means 2 multiplied by n square, n is 4. So minus, I will just write this minus, okay, minus 2 times minus 2, Mr. Mourad, times 16, yes, 16 times L0 is 20 times 20 times 2001 is 2097 plus, okay, plus 4 cubed is 64, or I will write it as it is. Okay, is 4 raised to the power 3. Okay, times 19 times what? Times 19,907. 19,970. So this one, learns, after calculation, I will get the now 0. Okay, that's why you wrote a 0. Okay, okay. So clear this part. We move to the next one, which is S3. After calculating S3, your strategies or procedures are going to get you on the good way to solve this polynomial equation. Therefore, now when k equal 4, set k equal 4, k it will be S4 minus 1 is 3, avoid R equal R from 0 to 4 because 4 is k, then C n minus R, 4 minus R because k is 4, 4 minus 1 gives 3, then n raised to the power R minus L0 for the cube to parentheses raised to the power 4 minus R times L R minus 1. After, let's say, distribution with R equal 0, with R equal 1, with R equal 2, 3, and 4, we reach this formula. When R equals 0, it will be and choose 4, L0q to the power 4. When r equal 1, it will be minus n to the power 1. And this is 4 minus 1 is 3. I wrote it here. N minus 1 is n minus 1. Then L0 of order q to the power 4 minus 1 is 3. And the minus, I put it here because when you raise a negative number to the power odd number, okay, you will get a negative sign in front of the output, okay. Therefore, then plus, when n equal 2, 4 minus 2, this one, 4 minus 2 is 2, and n minus 2 is written here, then n raised to the power 2 because r is 2, times L0 for the q squared, because 4 minus 2 is 2, and a negative number raised to the power 2, 4, and so on, it will be positive, no need to appear negative sign. Okay, when r equal 3 learns, we'll get c n minus 3 choose 1, and raised to the power 3 times L0 of order q raised to the power 1 times L2 of order q. Okay, plus when n equal 4, it will be n 4 minus 4 is 0. Therefore, combination of n minus 4 choose 0, it will be 1. Okay, n to the power 4 minus L0 of order 4 minus 4 is 1. It remains only 4 minus 1, which is the last one, 3. It will be n raised to the power 4 times L3 over the q. Therefore, learners, you can see that I will just put this into parentheses because L0 for the q to the power 4 is a common factor between this one, this term, and this term. L0 for the q, 3 times L0 for the q, in fact, is L0 for the 4. I will put this here, then I will just simplify the following. The combination n choose 4 minus n minus 1 choose 3, which is in fact a negative number. So it will be minus, okay, a 3, or combination 3 choose 1 times a combination n choose 4, L0 for the 4, plus combination n minus 2 choose 2 times n squared, L0 over the q squared, times L1 over the q minus what, learners? Okay, 1 and minus 3, it's written here, times n cubed, L0 for the q, L2q, plus n raised to the power 4, L3 of the q. Now, learners, just calculation. Okay, I will try to find this value. Okay, which this, I will write it here if it is possible. Okay, to appear. Okay, I will come there, learners. Okay, okay. So here S3, okay, S3 last part should be calculated, okay, using discriminant formula of Mr. Mourad Sultan Ezouidi. And this discriminant formula is a part of whole work, okay? It's a part of 14 years of work, let's say, diving into researches, and I finally found this formula. Not only this, in fact, so many, but in this level we'll use this. Okay, so just write here this minus 3 times 20 to the power 4. Why minus 3? Because minus 3 choose 1 is minus 3. Therefore, 4 choose 4 is 1. خلاص, I will just write this and that. It will be, I will just write minus 3 times L0 of order q raised to the power 4. It will be minus 3 times 20 raised to the power 4. Okay, plus 16, you see this one, 16 times 20 squared times 2097. Okay, we just write plus, okay, 16 times 20 squared, which is 400, or I will write 20 so that will never be confused. Okay, 20 squared, okay, okay, 20 squared, I will write this. Okay, good man. Times L1, learners. L1 is 2097. 2097. Okay, we finished this part. Now, minus 4 cubed minus 4 raised to the power 3. Okay, times 20 times 19,970. Okay, because this is L2 and this one is L3 plus what learners plus 4 to the power 4 is 256, but I will write it as it is so that the learners, students, teachers, and professors can understand the method. Okay, 4, okay, raised to the power 4, it had been written, times what? 340. 340. So this one learners should be equal to what? Equal, okay, equal, uh-huh, equal what exactly? Minus 12. Okay, I'll just repeat this learners. Okay, calculation. Okay, okay. So we have minus 3 times 20 to the power 4. Okay, plus plus 16 times 20 squared, which is 400, times 2097 minus 64 times 20, yes, times 20, times what learns times 19,970 plus 256 because 4 to raised to the power 4 times 340. 340. So just now equal sign. So it will be negative, okay, 12,533,760. And this one it will be negative 12 million 533,760. Okay, so why exactly we obtain the previous calculation? We obtain, okay, we forgot to multiply this by 20. Okay, this one. So now the correct answer is this one. Okay, so this is as 3. I will now close this one and I'm going to exactly to continue solving. Now, learners, you can see that from the previous polynomial to the power 4, I got a new polynomial. This one, it's called this new polynomial had been obtained from the discriminant formula of Mr. Mourad Sultan Ezouidi. It can be written as E of x equal x4 minus s0r, x3 plus 1 sr, x squared minus s2r, x plus s3 equals 0. Therefore, you can see that s0 is 0 and s2 is 0. We calculated before. Okay, and it remains only learners. Okay, only s3. Okay, just read this. R equal R, Mr. Murad, R equal to 0. Therefore, it remains only S1. Okay, I will write here S1 so we can understand this is S1 equal Mr. Murad. Yes. Okay. S1 of all the R. Okay, which is 31,152. Therefore, I will just replace S1 with 331,152 minus S3 is negative 12,537,760. Therefore, I will use now the discriminant of Mr. Mourad Sultan Ezouidi, which is not the same of the common discriminant for quadratic equation. Okay, this one is given by this formula, and this formula gives us a negative sign of this discriminant. Okay, which one the formula is that? Okay, is that? Okay. What is it, the formula? Discriminant formula, yes. Very important, this one. Okay. So, therefore, I will continue solving, okay, or writing my new polynomial to the power 4 relative to the polynomial, the let's say the old polynomial that we start with. I will just write S1 R dash. It's the discriminant, the value of the discriminant will be what exactly? It will be learners minus, I will just write this again if it is possible. Okay, I will write this so that you can understand exactly what happened. Copy, what comes here, enter. Okay, I will erase, let's say, this one because S2 equals 0. I will erase this one, S2 equals 0, no need. It remains also S0 is 0. I will remain this. Okay, it remains only learners x4 plus s1 of r x squared plus s3r. Okay, you can pause here, of course, equals 0. Okay, you can say let, for example, let x square, I'll just write this, let u equal, for example, or x or whatsoever, okay, u equal x square, and continue solving. Okay, therefore, learners, you can see that s1 r dash is s minus s1 squared minus s1 minus s1 all squared plus 4 times s3. We calculated s1 is 31,552 plus 4 times this number. I'll just use my calculation. So this one I will multiply by what? By 4. Multiply by 4. Okay. Then minus 31,152, I thought. Yes, 152 squared. Okay. It will be equal, learners. Okay. It will be equal to 1,020 million, negative sign, of course. Negative 1,020 million, 582,144. Okay. Now, as let's say the disk of Mr. Mourad Sultan Ezouidi, he is negative, put a negative sign in front of SR dash, you take a positive number. Therefore, I'll just proceed continuing. Okay. Therefore, learners, I'll just continue. So the value we found, let's say two value. I'll just see what happened to my. Okay, I'm still live. Okay, Anwar Hamdi. Okay, thank you, Mr. Anwar. Anwar, hello. Okay, your colleague Murad is inventing new theorems. Okay, and especially the discriminant formula of Mr. Mourad Sultan Ezouidi. Hello, hello. How are you? How are you doing? Yeah, good, good man. Okay, new forms. Okay, so learners here. This example is leading with finding exactly the roots of any polynomial to the power 4. Okay, with time we'll proceed 6, then 8, then 10, then 11, and so on. Okay, and pulling until okay. So therefore, thank you, Mr. Maher Zaidi. Maher, how are you? How are you doing? The best teacher of English. I love you so much. Okay, we are still learning from you, Maher. Huh? We are still learning from you because you are the most important, the most awesome teacher that I met one day, and we are still working together in the same school. Okay, we continue, Mr. Maher, just to continue proceeding my researches in mathematics, and this research will be held to everyone. Okay, uh, so here, learners, we can say that x squared is minus s1 over the r plus the root of minus s1 of r, r dash, not double dash, because this is the discriminant. Okay, from the discriminant formula of Mr. Mourad Sultan Ezouidi, the Tunisian researcher of mathematics. Okay, we can see that negative, it will be negative 1, s1 is positive, and here negative sign it will be negative 31,152 plus what, learners, you can see this one because we told that is we put the negative sign in front of it because minus s1 r dash is negative 1,020 million 582 144. I will put negative sign, so it will be this one. Therefore, learners, I will just write 1,020 million 582 1144 as the product of two numbers, 4 multiplied by 2000, okay, 255 million 145,536, and the 4 here, it will be out of the root, square root will be 2, so that I can simplify by this one. Now let's say simplify. I will just simplify this, learners. I will divide this by 4, okay, first, okay, so it will be equal to, okay, 255, 14, 55, 36, okay. Then we continue, learners. We have 31,152 divided by 2, okay, divided by 2. I will obtain exactly, I will obtain exactly 15,576, and don't forget about the negative sign, okay. Therefore, I will appear 24 here, okay. I will divide this by 24, okay. It will be equal to 649, 649. Then I wrote it here, make 24 times negative 649, okay, because this one is negative. Then this one, learners, I will just go back to divide, what exactly to divide, okay, to divide this by 24. I will divide this by 24, learners, okay. I will make paste first, divide by 24 because 24 is a common factor, okay. Divide by 24 squared, of course, okay. 24 squared because inside the roots, it will be equal to 4, okay, 442,961, 442,961. Then I will continue now. The formula of Mr. Mourad Sultan Ezouidi tells you that xk belongs to 0, 1 is the root of this one. Okay, as the root, I will paste this. Okay, so that you can understand is equal to a root, Mr. Mourad. Okay, of this value, which is equal to root of this. Okay, okay, because we appeared 24. Okay, so it will be okay, okay, here in this part it will be, so L0 over the Q is 20 plus the root of this. Why I put here exponential ik pi? Because one time is positive and the next is negative, okay, because here it's exponential 2k 2ik pi. Then I put the root, it will be this one divided by 2 gives ui exponential ik pi, which is equal, learners, to this value. Okay, I will simplify 4, it will be outside, okay. Therefore, when it will be outside, it will be 2 divided by 4, it will be here 2. Then 20 divided by 2 gives, let's say, 10. Over 2, I simplify only by common factor 2. Okay, now, learners, I will check now. I can use GeoGebra, okay, to check this equation, okay. Therefore, I'll just tell you something that maybe some mathematics teacher or professors don't know about this one. GeoGebra can solve 10 to the power 5, 6, 7, whatsoever, even if they use artificial intelligence, okay. But if they can use my artificial intelligence, they can solve any polynomial to the power n, and this is true. Is it true? Okay. Therefore, I will go back. Okay. Therefore, this is the first roots. Okay. There is another root, x squared equal minus s1 of r minus root of minus r only, not double dash. So because this is plus and this is minus, the same calculation. Okay. I will just obtain 200. I obtained 24 times 649 plus root of 442,961 exponential of 2k plus 1 I pi over 2. Why comes I pi 2k plus 1 I pi over 2? Because this is negative sign. You see, minus 15,576 minus root of 255,145,536. This minus sign, it will be after that put into the square root. I will just write as exponential of I pi. When you put the square root, it will be exponential of I pi over 2. Okay, and before we got also exponential ik pi. I'll just multiply this by 2, it will be 2 ik pi plus 1 I pi over 2. This is, I will make I pi as a common factor. It will be 2k plus 1 over 2 times I pi. Means there is this root, it's complex. Okay, it's complex number written as a plus ib, z equal a plus ab. This is the first solution. Therefore, this is the solution of x. The solution of x4 minus s0 x3 plus s1 x2 plus s minus s2x plus s3 equals 0. Therefore, now to find, we told that xk between 0 and 1 is the root of this one. Okay, 24 times ik times ik times okay, I'll just here put okay, just a moment. Yes. This is xk. Now I will put 24. You see, it's 4 times 6. I put 6 here, then I sort out or write 2 as out of the square root, because for the root of 4 is 2. Okay. Then I will place this here in the formula alpha. Let's say the roots of my polynomial when k equals 0 and 1, 2 roots here, and here also 2 roots, 4 roots in general, to be L0 of order cube plus xk, k belongs to 0 and 1 over 4. So this one, it will be 20 divided by 4. I will simplify by 2, and here by 2, it will be 10 over 2 plus. This is 6. Okay. This is 6. It remains only 6. Okay. Yes. To remain only 6, like this one exactly, times negative. Okay. Okay, this is, we told minus this one learns. Okay, minus is outside. Hello. Then this is plus, and also this one is a plus. Okay, so this is the roots. Now I will guess the GeoGebra. Okay, it works only with 3 and 4, but 5, 6, 7, 8, 9, 10 can't solve. In fact, okay, but Mr. Mourad Sultan Ezouidi, using his own discriminant formula, okay, everything will be clear for you. And every learner, every teachers, everyone, everyone that he is looking for, understanding polynomials, understanding the relationship between LRPQ relative to SRPQ. It's very important to use the method of Mourad Sultan Ezouidi. Therefore, learners, I will go back now. I will go back to GeoGebra to show you something. Okay, GeoGebra, GeoGebra. You can solve polynomial more than 4. Catastrophe really. But Mr. Mourad Sultan Ezouidi, okay, he got a point how he can find out all the roots of any polynomial to the power, okay, to the power 4, 5, 6, 7, and so on. Okay, and I prepared so many books. Okay, published a few of them. Okay, in addition, University European. Okay, but they didn't accept books written in English. I don't know why. Okay, because I already, let's say, upload 2 books, one in French and the other in books. They told me that our policy can't accept the English version. I don't know. Okay, I will just go back, learners, to this one. Okay, I will close this, or I will put after. Okay, I will come here, learners. Now I will come here. It is possible, of course. Okay, I will go to copy my polynomial to the power 4. Okay, so this GeoGebra only can find the real roots, real numbers, roots that are in the in the body of real numbers, but in the complex number they can do it. Okay, and this is also, it's a mistake. So therefore, this is the polynomial to the power 4. I will paste it, then I put it there. Okay, okay, to check my work, and here also to check this work. Okay, what happened? Control. Okay, no problem. I will write x. I will write x. Okay, 4. X4. This is x learners minus 20 x3 x to the power 3 plus 2097 x square, Mr. Murad. Okay, then okay, minus 1970 x only plus 340. Okay, so okay, enter. Even the graph, he can do it. Okay, but I will come here. I will tell him, please. Okay, I will tell him, give me the roots at least. Okay, this method of GeoGebra make, let's say, a multiple of test. Means using the using the artificial intelligence. Okay, and okay, means he will use the remainder theorem. Okay, check all the points. If it is zero, so he can reduce the order, the degree, and so on till he find this last answer. Okay, I'll just make here a duplicate special point. Okay, okay, special point. Okay, this is about the graph. Now I am looking for okay, setting, delete. Okay, delete this one. Oh my god. Okay, again, x4, x to the power 4 minus 20, minus 20, Mr. Murad, minus 20, x raised to the power 3. Okay, then plus 2097 x squared. Okay, then minus 1970 x only plus 340. Okay, equal 0, of course. Okay, and try to find the special points. Duplicate, solve. I will tell him solve. Solve. Okay. Okay, you see this one, and this. Okay, you see the precise work of Mr. Mourad Sultan Ezouidi. I will try to full. I will make full. Okay, you see this one comes here, Mr. Mourad. Okay, okay. I will focus only on this and this. Okay, so this one it can give real numbers. This one complex numbers. So a GeoGebra can find out the complex numbers. Okay, and this one it found the GeoGebra find this by excluding the zero or reducing the power of polynomial till he obtain this one. Okay, but Mourad Sultan Ezouidi he used his own formula that works whatsoever that works for any polynomial raised to the power n. You see this one, learners. This one, okay. I will try to reduce this so that you can see. Okay, you can see this. What is it? Okay, I will. Okay, so I will make like that. I don't need the graph. Okay, therefore I make like that. You see this one, learners? I will try to put. Okay, no problem. So also I will put this here. It's better. Okay, you can see that. Go down, Mr. Murad. Okay, like that. So that you can see the precise work of Mr. Mourad Sultan Ezouidi. Here, yes. Good man, yes. Good man. Okay, this is complex number, of course, and this is real numbers. Okay. Okay, we come here. Okay, up. This one, yes. So you can see this one minus, this is 10 minus 6, then root of this number minus this one over 2. Okay, so this is the first value. Okay, and the next value is the opposite. Is that what it's hidden? Okay, so now learners, why I told you that, because if GeoGebra, if you give work to GeoGebra to solve, he can solve. I'll give an example. What is GeoGebra? This one. What is GeoGebra? Okay, GeoGebra. Okay, we'll put this here. GeoGebra. Okay, now I will give you this example. Okay, for example, 7, okay, minus 20, x, for example, 5, okay, then plus, for example, okay, here 4, I would just suppose this is 4, okay, plus this is x, خلاص. So, equals 0, of course, comes here, okay, here, he found only 3 roots. He told that is negative 13.34, then 0.02, then 2.13. We check 1. Okay, I'll check 1. Okay, so I will just write negative 13.34. Raise it to the power what? Raise it to the power 7. Okay, then minus a 20 times uh, between parentheses negative 13.34, close the parentheses, raised to the power 5, okay, plus 2097 multiplied by 13, negative 13.34 raised to the power 4, positive number 13.34 raised to the power what, learners? To the power 4. Then minus 19970 times between parentheses negative number negative 13.34, close the parentheses, then plus 340. So this one has to give you a 0, okay, not 26,000. It will be 26,319,593. This is GeoGebra solve this one. So it's false. Okay. So I told solving equation. This is the equation. It's impossible. Okay. So you can see that Mr. Mourad Sultan Ezouidi at least focus on GeoGebra, that or MATLAB, that all professors use and give us a wrong answer. Okay, so when we put x equals negative 13.34 in this equation, you should find 0, not 0.1, not 0.2. Okay, with an arrow, with a zero estimation error, without error estimation, sorry. So you see, means that okay, I just close this parenthesis. Okay, uh, let's be not be saved. Okay, no problem. It's not our problem. So, learners, thank you for listening. It's Mourad Sultan Ezouidi with you always, and I wish that everything was clear for you. Thank you and goodbye. Okay. Okay, Mohammed Hamdi. Thank you, Mohammed Hamdi, for your support. Okay, just recall for what we did exactly. We solved a polynomial to the power 4, and we We use the discriminant formula of Mr. Mourad Sultan Ezouidi, and this formula it's a part of whole work. Okay, during 14 years of work, I prefer telling 14 years. Okay, not 14, not 40, not 40, but 14. Okay, thank you. Goodbye. See you next time. I love you so much. Thank you. Goodbye. I'll just close the stream. Okay. Okay. From where Mr. Murad, you are going to end, yes, end.